So I'm calling our host for our next session, Michel BERTHÉLEMY, who is Nuclear Energy Analyst at the OECD Nuclear Energy Agency and is also the president of our section, technical section number 8, Economy and Energy Strategy, as well as our panelists, so Mark Hartley, Aude PUGIN, Tilly Spencer, Bertrand MICHOUD, and Julia PYKE, who will join us from UK. Thank you.
If you remember, yes. Excellent. And then there is 2 seats for the virtual participation of Julia. Okay, well, thank you very much. We are now going to move to the UK for a very exciting and rich panel on the progress with EPR in Great Britain. We see a lot of momentum at the moment regarding nuclear in the UK, and progress with the EPR project has a lot to do with that in terms of reviving the nuclear supply chain in the UK over the last decade or so, and the overall ecosystem. Maybe to put things in context, and I'll be very brief because you're here to hear about the speakers, not from me. I think it's fair to say that Hinkley-upon-Sea is currently the largest infrastructure project in Europe as a whole. I think, see Mark nodding, that's good. And Sizewell C is certainly in the UK the leading project for next new build, and we will hear about the new approach in terms of delivery and financing that is envisaged there. I would also add that progress with the EPR is now leading to renewed ambition for nuclear in the UK, linked to net zero objectives that we heard earlier from Philippe, and also rising concern in terms of security of supply. And last but not least, you know, this success, ongoing success in the UK, is also a big source of inspiration for the new build plans in France in terms of project management, in terms of delivery, in terms of supply chain, in terms of financing, and these are all very interesting topics we'll be covering today. So I'm very grateful today to have a very rich and diverse panel. I'm also very thankful to those of you who came from the UK, because there was some strikes yesterday, not strike in Paris, but for once strikes in the UK. So thank you all for making arrangement. Julia didn't quite make it, but she'll be joining us virtually, and thank you very much for that as well. So we will be starting this conversation from the UK, from Hinkley-upon-Sea, with Mark Hartley, who is the technical director of Hinkley-upon-Sea, and then we'll be hearing from the nuclear supply chain with Aude PUGIN from APCO Technologies. Tilly Spencer will tell us about how Edvance is supporting both Hinkley-upon-Sea and planning for Sizewell C. And then we'll have Bertrand and Julia to tell us about the approach for Sizewell C in terms of delivery and financing. So without further ado, I'll give the floor to Mark for a presentation on the latest update with Hinkley-upon-Sea. Mark, the floor is yours, and you have the thing. Yeah. Whatever you prefer.
So good morning, everybody. It's a great pleasure to be here to be able to talk to you and tell you about Hinkley-upon-Sea. It's interesting to reflect. We just heard about the EPROG and the sort of expanding family and the connection. So what I'm going to try and talk about today is, well, of course, to give you a view of the project and where we are and show you some bits about that. But I'll come to those pictures and updates in a moment. And first, I want to set a bit more about the context and talk about the learning within the project, how we gain from others that have gone before, and how we see that learning going from one unit to the second unit, and how that might be of great benefit to future projects like Sizewell. So think about, well, what is HPC? Of course, it is a twin unit EPR in the southwest of England. We often say that it is units 5 and 6 of the EPR family. So of course we follow on from all of that great experience from Okulutu, Flamanville, and Taishan 1 and 2. But like any of these things, we have a different regulatory environment. So it isn't a complete replication. It is a continuation of the family, but there are some things for Hinkley then that have become unique as you make it ready for that UK regulatory environment. And that in itself represents a challenge. Of course, within this, the model is here, it is fully funded by its shareholders, 2/3 EDF, 1/3 CGN. And we've had to develop all of the skills, capability, and so on to be able to do this project. You have to recognise within the UK, it is a long time, 30 years since the UK did this kind of new build programme. So you have to think of this as being, a decade in development, a decade in construction, at least 60 years in operation, I would expect more, and then into defuelling, decommissioning. So of course we are planning in well over 100 years here, multiple lifetimes in terms of our workforce. And for me, that's one of the things that makes nuclear unique. Our supply chain. Truly global in terms of the suppliers that we have. And we couldn't, of course, succeed in this endeavour without the support of all of those suppliers to be able to deliver what's required for the project. Our Tier 1 suppliers are spread across 12 countries, roughly 450 live contracts at the moment, with Tier 2 suppliers spread across 42 countries, and we see the majority of that across UK and France. And 97% of the supply chain is European. So huge input right across to be able to bring all of that together to deliver the project in the southwest of England. So if we think about, though, these units 5 and 6 and the learning that, if you like, they bring and they will leave behind for other projects, it's interesting to go through that and look at not only what we've learnt, but also how we now get things ready for, hopefully, what will be units 7 and 8 in the UK, just on the other side of the country, in Suffolk, when we build Sizewell C. And this, the aim is to be a true second of a kind, so that it really is an absolute replica of the Hinkley EPR. So this one will be a sibling rather than just a cousin. As we think about where we are with this, well, of course, the design work to comply with the UK's own regulatory regime is all complete. We have now qualified equipment and technology throughout the supply chain. We've learned from the experience, which I'll come on to in a moment, with units 1 to 2 in Hinkley, and how we deliver that benefit in construction. And we have the systems and data, which I think sometimes we forget when we talk about these projects. In this day and age, that is a huge endeavour. Hinkley will have a complete digital twin, which is fantastic in terms of for the future operator. It saves time in construction, and it benefits enormously in terms of transfer of learning to future projects. But the sheer magnitude of that, we sometimes forget when we talk about it in that way. And of course, we have the skills and capability. All of those things that have been developed across the supply chain, the construction capabilities have to be maintained with future projects across Europe in order for us to be able to have those capabilities available. We've also set up, in terms of having EDF centres, to be able to bring together some of those engineering capabilities with a model that allows us to support plants with different ownership structures. I'll finish here with thinking about the socio-economic impact of a project like this, and it is huge. Hinkley has a massive impact and has had this impact in the local area. When we think about improved social mobility and examples like already 1,000 apprenticeships having gone through in terms of the project alone, something like 14,000 jobs in the local area throughout the project and its suppliers. So it makes a massive difference to that community as well. Thinking then about the replication and just some examples to give you of this learning and the transfer of learning from our first unit to our second unit. And this is what gives me confidence as an engineer that actually replication works, And we see it transfer from one project to the next. And I can measure it because these two are side by side. They're the same design. I can see what's happening. So if I pick a couple of examples, I take our Unit 2 versus Unit 1 and think about lifting of the first liner ring. And effectively, only 11 months apart, as planned, 25% quicker, Unit 2 and Unit 1, with effectively thousands of hours less effort. So great efficiency improvement and a lot faster. Pick other examples of things like our containment structure and bringing in all of that experience of how we now use specialized formwork to be able to build the inner and outer concrete containments at the same time. Much more efficient on Unit 2, and the whole thing goes up around the liner a lot quicker and a lot more easily. So we have a bit of sport between the teams, with Unit 2 chasing Unit 1, so that their ambition is to catch them and overtake them. Clearly, we manage those resources carefully. So if I move on to update on the project as a whole, some of our key highlights. Of course, it's been a challenging time. You look back at these things and I mean, who would have predicted a pandemic? Despite all of that, we've made huge progress on the site with the civil construction and now moving into the mechanical, electrical and HVAC, which is the MEH phase that's referred to. We see our Unit 1 growing out of the ground, being taller and taller as the liner rings are welded together. The Unit 1 dome is complete. It's ready to be lifted. All of the marine tunnelling has been done, a huge endeavour. We've now got a lot of equipment that's arriving on site, it's ready to be fitted. So all of these things are very tangible, very real. Great progress with things like our steam raising equipment from Framatome. Again, seeing the RPV ready to be delivered at the end of the year. The simulator building's now built. It's got people doing operator training in that building. It's fantastic to see, to go there and see our future instructors going through, learning from what's been done at Flamerville and what's been done at Okiloto, Taishan, so that they're ready to train the next set of operators for Hinkley. And they are there now on site in the simulator building. So a few things in terms of just bringing us right up to date, a few pictures of where we are. We've got Unit 1 across the top, starting to see the liner for the reactor rising out of the ground here. This has now got the second ring attached. There is a third smaller ring to go on before we lift the dome, which will be ready at the end of the year with that lifting that ring on, so that we'll do dome lift next year. For the turbine hall, much of the walls are complete, ready to put the steelwork around so that GE can start work in a safe environment to bring the turbine in and start that construction. And the volute is the structure that goes around the main coolant pumps in terms of bringing this in. So this is this incredibly large pumping station. It has to be very deep because of the huge tidal range for Hinkley. It's a 14-metre tidal range. And you can see then below Unit 2 starting to catch up Unit 1. In the same way, lots of progress with delivery of equipment. You can see there our emergency diesels delivered, waiting, ready to be fitted on site. They're all tested, qualified, etc. A number of other things, pictures of the reactor pressure vessel. So you see switchboards, our instrumentation and control now in testing, so actually starting to connect up these systems so that we prove the systems work together before we get them to site and fit them. And lastly, the polar crane, which I'm just going to talk a little bit more about, just as a sort of a mini case study to think about some of the collaboration that's involved in terms of these challenges. I can't emphasize enough how important it is to have this approach of a family and to be able to collaborate when we're in construction and operation. I've seen it throughout my career in operations and now see it strongly in my career in construction. And this is a great example where with the Polar crane, Hinkley benefited greatly from APCO's experience as a supplier to Flamanville, bringing across all of that expertise, bringing improvements to the mechanical and electrical design. One of the big challenges, though, is that the regulatory requirements are different in the UK. And this actually meant quite a significant redesign to some of the control systems. Going through that in partnership together has meant that actually we've solved that issue, brought forward now the solutions which mean that the Polar crane is in essence ready to be delivered. And I don't think either party could have done that alone. So again, I think it's a great example of that broader family and the collaboration that's important. So if I look forward now, and just say very briefly, well, so where are we in terms of, as we go into the remainder of this year and think about next year? Well, of course, civil construction continues at a pace. You know, our plans are to pour, you know, roughly 200,000 metres cubed of concrete this year. It's a huge number, and significantly in excess of what we did last year. We move into what we call the bulk phase for MEH. So we're really starting now to bring together all of the pipe work, the supports, the electrical cabling, our HVAC. Those things start in anger as rooms are now being handed over on site. More and more throughout this year, we will see, rather than something that looks like a civil construction project, you'll start to see buildings with rooms which actually we're now fitting a lot of equipment into. That's already the case where I'm now looking at a site and looking at sort of 3 floors below the ground and with people starting to install equipment there. Reactor pressure vessel will leave Framatome and be ready to be shipped at the end of the year. And of course, our plan is to install the pressure vessel next year, along with lifting the dome on top of the containment building, also in 23. Big, iconic milestones. I'll mention the tunnel heads. We think about these in this marine phase of work. Hinkley has a particularly demanding marine phase of work. We've got seismically qualified intake and outfall tunnels that are over 3 kilometres long to get out into the Bristol Channel, and because of the tidal range that's seen at the site. All of that work with the tunnels is complete, and we now, throughout the summer, will be lifting those intake and outfall heads into place. Sounds straightforward when we say it like that. The largest of those is a 5,000-ton lift. Will require multiple barges operating in synchrony to be able to do that. So this again is another example of elements which have to be brought together to do that kind of construction. And of course, with our engineering, our focus now is to close out the last elements of execution design so that we are firmly into very much the construction element and all of that problem solving. So I'm going to finish the presentation with handing you over to a colleague and a good friend of mine, Nigel Cann, a recorded video to give you a tour of the site so that you get to see a recent video of it and what it actually looks like today. He says, hoping the technology works.
Welcome to Hinkley Point C. Today we have around 7,500 people working here at the site. Recent events have really brought into focus the importance of this project from an energy sovereignty, security and sustainability point of view, and also the important part it plays in net zero by 2050. Today we're going to show you the great progress we've made. Follow me. From this position we get a great vista of Unit 1, especially the Nuclear Island reactor building behind me. You can see we've made great progress. We've now grown to 34 metres. And you can also see the big equipment hatch which we'll introduce the reactor pressure vessel and steam generators through. We have one more smaller ring now to fit, and then we move on to actually fitting the dome, which is behind me here on the left-hand side, which is actually completed. Let's go inside the reactor building. Welcome to Unit 1's reactor building. So you can see the great progress we've made since the last time we've done a virtual tour. Over 2022, we'll start to build the walls. Here, the radial walls are up to around 19.5 metres, which is pretty much at the top of where this line of ring currently sits. And I'll stand right in the area where the reactor pressure vessel will go. That reactor pressure vessel is due to leave the factory at the end of 2022 and will actually be fitted here through the equipment hatch in the second half of 2023. You also see we've introduced some large columns here and look to get this level up to around 19.5 metres by the end of 2022. These columns themselves weigh around 200 tonnes, so fantastic piece of engineering. As well as completing the important construction activities, we have to think about the future and training our operators. Let me take you to our simulator building here, where them operators will be taken through the important training activities they need to operate this huge plant. So we've popped into our fantastic state-of-the-art operational training centre, and we're here in the gold full scope simulator, where our operators can really hone their skills. An operator takes around 2 years to complete their training in both normal operation and fault scenarios. The operators themselves will be actually tested and assessed in this building so that they're on top of their game before we allow them to operate this huge piece of UK infrastructure. So welcome to the electrical building. This will be the beating heart of the electrical system for Hinkley Point C. You can see we're making good progress in installation of all the containment, which will carry all the cables, and actually the heating and ventilation systems behind me. The plan this year is to really gain momentum with mechanical, electrical and HVAC installation. We plan to hand over 300 rooms and start working 280 of them rooms. As you can see, our teams behind us are starting to make really good progress in installing the equipment, and they'll be joined by lots of colleagues over the next 6 months. Welcome to Hinkley Point C Unit 1 Turbine Hall. Great progress since our last plant tour. We've actually built the external walls, as you can see, up to the level 2. The staircases are going up, and we've actually put a 2,500 cube concrete pour on the top of the blue columns that we see last time. That will eventually house the biggest turbine in the world. The next key steps in this area are to complete the concrete walls, to actually build the staircases, and then the really important piece really for us is to build this structural steelwork. So about 64 sequences of steelwork that need to go in. On top of that, we'll place a concrete slab, and then we'll build the steelwork up to house a 300-ton crane. We'll clad the building, and that then will allow our General Electric colleagues to come in and actually start assembling the turbine unit itself. So we're now at the opposite end of the site to where we started. Behind me you get a really good view of the reactor building, the turbine hall, and where we are now in the heat sink. The heat sink itself started as a 30-metre hole. As you can see, the structures are pretty much up now to ground level, and these will house the big drum screens that will filter out all the debris from the sea that allow the CRF pumps to pump the water into the turbine hall. So fantastic progress here. We expect this building to be above ground level by the end of 2022. We're also starting to build the volutes, which are the big pumps casings, which is a really intricate civil structure. In front of me, all the work in the marine area, we've actually completed all of our tunnelling. So we've got 2 tunnels now that are 3.5 kilometres out to sea, one that's just over 2.8. And this year's a really exciting year for us because we actually start to land the big intake and outlet heads, which the largest of which is 5,000 tonnes. So really big marine campaign this year, really exciting work over the summer months. That concludes our virtual tour for today. Obviously we've not been able to cover all the areas that are going on here at Hinkley Point. We're making really good progress in our grid substation where the 400,000 volt lines have been installed into the site. Transformers are being fitted. On Unit 2 there's also great progress, and we're also seeing between 20 and 30% efficiencies in the construction activities, which is vital to follow on to the new build projects, including Sizewell C. I hope you enjoyed the tour, and I look forward to seeing you next time.
Thank you very much, Mark, for the presentation and this very interesting virtual tour. I think we all hope here to have the opportunity to have a physical tour at some point in time. Probably a few of the people in the room already have. now I turn to Aude PUGIN. Aude PUGIN, you're the CEO of APCO Technologies, which is very active in the space industry, but also in the nuclear industry. And as we heard from Mark, you've been supporting Flamanville and now working on Hinkley-upon-Sea for the delivery of the Polar Crane. So we very much look forward to hear your perspective from the nuclear supply chain about the Hinkley-upon-Sea project and the key challenges you faced and overcome together, as I understand. I'll let you, whether you want to take it from here or from over there, up to you.
Good morning, everyone. Very happy to be here. So APCO Technologies is active in space, nuclear, shipbuilding. We are the designer and builder of the Polar Crane for Flamanville, and also the designer and builder of the Polar Crane for HPC. Thank you very much, Mark, for the introduction and for showing us as a case of collaboration. It was a great collaboration indeed. So I have about, I believe, 5 to 7 minutes to tell you what a Polar Crane is, what it does, to give you a flavor of it. So the role of the Polar Crane, it's a high capacity and high safety lifting equipment. It's located on the top of the reactor building, and obviously in the design we need to take into account a number of safety functions to maintain at all times the load, to guarantee the integrity at all times in all circumstances of the Polar Crane. This requires a very specific and very advanced seismic analysis knowledge, and of course there should be no point of failure in the design of the Polar Crane, so it means a number of redundancy in the movements, in the lifting functions of the Polar Crane. So the role of the Polar Crane, what is interesting is that it has a role all through the power plant's life cycle. So it installs, maintains, dismantles heavy components in the power plant. So it's construction, operation, and dismantling phase. Obviously, today I will focus on the construction phase because this is the one that is currently happening right now. To give you a flavor, we saw a tour of HPC. I have to say, having been fortunate to be there twice, it is very energizing to see the scale, to see the magnitude of what is the biggest construction project in Europe. So scale, magnitude, to give you an example, so our Polar Crane is of a weight of 750 tons, a length of 45 meters, height of 20, and width of 50. So how are we going to mount that into the power plant? So first, it's going to be fully assembled on the ground, except for the runway that is going to be pre-installed in the reactor building. So fully assembled on the ground, trolleys that you see here installed on the Polar Crane, electrically connected, and then the full Polar Crane will, in one set, be lifted by a big car and started on the top of the reactor building, then on the railway, adjusted thereon, and electrically connected. The main components of the Polar Crane you will see actually in the trolley's capacities. You have a main trolley with a lifting capacity of 320 tons. This is mainly for the construction phase, and then more for the operation phase. You have the 35 and the 5-ton lifting capacity. I'm not going through to bore you and to go through all the functionalities of the components, but Mark said that we managed about 35 subcontractors, and I think these components are a great example to give you a flavor of how we managed the supply chain. Initially, it was the same subcontractor that was in charge of the quadrilateral, so the 2 beams, and of the main trolley and the rotation budgies. And on top of that, as it was said before, we tend to forget it, but this was all manufactured in the middle of the pandemia. And the subcontractor that we used underestimated the overall nuclear quality process requirement, its impact on its organization, on schedule, particular in the middle of COVID. So challenged to meet the upgraded welding requirements in terms of welder's authorization, in terms of follow-up and documentation of the welding books, of the welding records. So we we came in September 2020 with a change proposal of the supply chain, and this is a great example of collaboration, of proactiveness, of understanding between EDF Energy and ourselves. We said, well, look, it's probably too much to give these three components to the same subcontractor. Let's do a change, let's alleviate, let's optimize, let's focus on the quadrilateral, and we awarded the trolleys and the bodgies to two different subcontractors. Changing your supply chain in the middle of a crisis is difficult, but also we could have done no change, or we could have changed everything, because also keeping the trust and building with this subcontractor that was struggling a little bit with the requirements and leaving him with something as essential as the quadrilateral, I think it's a great example of overcoming challenges of building, and the supplier that we have that achieved the quadrilateral is absolutely fit and the best knowledged subcontractor that we can have to perform Unit 2 first, and fortunately the 2 units of Sizewell. So we are, with the Polar Crane, on the critical path of the project. I have been told that a few times. We are in the construction phase. The dome lift is key. We heard a lot about the pressure of the dome lift for the advance of the project, and of course for the showcase that HPC is for Sizewell. So we are the first lift equipment that is installed just before the dome closure. So it has been a challenge to work collaboratively with all stakeholders to adapt the design. Because obviously we are the designer and builder of Flamanville 3, but we thought we were replicating, but we are obviously building a first of a kind in terms of INC, in terms of safety cases. So there has been ongoing definition of the design, of the requirements, of the technical specification. You have to manage interfaces. This is common in our projects, but always challenging. I mentioned it, the INC qualification, development, the safety cases completion as well. And last but not least, we're not there yet, but we are currently starting to dismantle the Polar Crane for transport and installation on site. And transport, since the dramatic Genova incident in 2018, where the bridge collapsed, it means that also transport is a project per se in terms of the requirement, in terms of the stress justification of the load on the road that you need to justify all through the transport across Europe. So building a long-term collaborative relationship. I said we spent a lot of effort freezing the design, coordinating inputs, speeding up the INC and the safety case developments, managing this supply chain with the really, I think, illustrative example I gave you before. And I think really in a project of this magnitude, of this complexity, it's not the lack of challenges, the lack of problems, it's how efficiently, in which spirit of cooperation, and how fast you overcome them. And this is, I believe, really the concept of a growing family. Last slide, this is a picture that was taken last week with all the people that have been involved in our organization at APCO in the achievement in the manufacturing of the Polar Crane. Team spirit, we have two values at APCO Technologies, customer focus and team spirit, which I believe are the external and internal side of the same value. A great cooperation, building together internally and with our partners. So we are also very proud to be part of the growing EPR family. Thank you for your attention.
Thank you very much, Aude, for reminding us first how much of a feat of engineering Polar Cranes are and how much critical path it is, and also, you know, the importance of collaboration. And this is a very inspiring story for us to hear. I'll have some questions for you, but I first move to our next panelist, who is Tilly Spencer. Tilly, you're a bit of a bridge between Hinkley Point C and Sizewell, because you currently heavily support Hinkley Point C, but you're also gearing up to Sizewell. So very much look forward to your perspective about, you know, how Edvance is approaching this and what you've done in recent years.
Good morning, everyone, and very happy to be here to say a few words about what Edvance is doing to support the UK EPR projects. Maybe I'll just start by saying in 2 words what Edvance is, and then particularly the role we have on HPC, and then, as Michel rightly said, making the link as to how we're now preparing ourselves for Sizewell as well. So Edvance is part of the division of new nuclear projects and engineering within EDF Group. On the HPC project, we're part of the Responsible Designer Organisation. And we have a role to deliver the design for HPC, but also to integrate that design with the engineering and the design that's delivered by our supply chain partners, both in terms of firstly specifying the requirements for the equipment that will need to be within the power station, but then also carrying out the technical oversight and surveillance of that work to ensure that in the end what actually gets delivered to site is going to comply with the requirements for the design. And then we also have an ongoing role to provide that designer and engineering technical support during the construction phases and preparing for commissioning. Obviously, at the moment, we're at a phase where we're coming towards the end of the detailed design activities on HPC and very much transitioning now into a phase where we're providing much closer support to the HPC site directly for the to support construction and ensure that we've got the right engineering and technical support locally in the UK to ensure that the HPC project remains on schedule and that any topics and issues that do arise, we're able to address those in a timely manner. I work within Edvance UK, and we have got a team now that's based in Bristol and on the HPC site of around 500 engineers. They are predominantly working to support HPC, and I'll say a bit about what we're doing in order to prepare for Sizewell. The design for Hinkley has been managed both from France and the UK, but really with the majority of the design delivery being done from the teams in France. But now, as we start to prepare for commissioning and really supporting the next phases of construction, Mark talked about the mechanical, electrical and HVAC erection, the need to have a growing and strengthened, competent organisation from the responsible designer in the UK becomes more and more important in order to be reactive, in order to be close to the teams that are actually doing the construction, the licensee organisation, and really ensuring that we're providing that close and reactive support to the project. Obviously, we cover the full range of technical disciplines, and really what we're looking to do now on HPC, starting in 2022, is to progressively develop the skills and the capability based and using the strong basis that we already have to have, I would say, a competent and a capable designer organisation, very closely linked to the teams in France, but progressively more autonomously led from the UK as we think about preparing the future of the UK EPR projects. That basis provides us with a very strong platform to prepare for Sizewell C replication. The obvious things, what we will replicate for Sizewell will be ultimately what is built, what is installed at Hinkley Point C. So both the data, the documentation, the design that we want to replicate will be the design that is on the site at HPC. The people that we want to work on Sizewell C are the people with the capability, the skills, the knowledge and the experience from HPC to ensure that we're really bringing all of that knowledge and all of that learning and making the replication for the UK EPR a success in the UK. And so what we're really looking to do is to develop and evolve our organisation to have one that really streamlines the skills and the experience and especially the knowledge transfer from the HPC project to the Sizewell C project within the designer organisation. For Sizewell C, we will work as part of a joint venture with the rest of the EDF group to deliver a replicated design for Edvance. It's the nuclear island, along with the other DIPNN entities for the conventional island and the balance of plant, and the overall integration, the technical integration of the plant as well. One of the key strategies that we set for Sizewell is that the need to have an engineering organization where the center of gravity was close to HPC, close to the site, and more strongly led from the UK was a really important point of our strategy. And so we're preparing for that, really looking at how we can take the experience and the knowledge of the people, particularly those people from the designer who are working on the HPC construction site, who will have the knowledge, the experience, and also then the final design that's built, and ensuring that can then be transferred to prepare for Sizewell, and then ultimately we hope to deliver that replicated design. So perhaps one final point is that once we've done those things, we see that there's a real benefit in having a well-established organization in the UK that's there for the long term. So as we move towards operations of HPC and into the operational phase, the enduring support from the responsible designer, becoming a design contractor, if you like, to the future operator is really important. And so we're also thinking about how, on the basis of the existing teams, skills and knowledge that we have for HPC, that we hope to also use for the benefit of Sizewell, that is then an enduring presence in the UK to become part of the overall engineering model that will support those EPRs in operation long term. So I think three things that I wanted to just finish on before I hand over to Bertrand. The first is that we're really working to develop the Edvance organization in the UK, building upon the existing skills, capability and knowledge that we've got to have an engineering centre that is there and competent for the long term in the UK. The second thing I think that's really important is that we need to ensure that we've got the flexibility to support different projects, different owners who are going to have different organizations and ownership models. So we're not in, if you like, the French organization in an operating world where everything belongs to EDF. We very much recognize that we need to be able to serve and service, successfully deliver to different clients who have got different shareholders and who will have different organizational models themselves. And finally, the key to success in all of that is always about people, people and the skills of those people and the experience of those people. So being able to retain the ones that we've got, really develop them, and that's just not just about our own employees, but it's also about the close collaboration we have with our strategic partners. So looking at that much more holistically across the UK nuclear industry, and really thinking about how can we best harness and garner and keep that capability long term. Thank you very much. I'll hand over to you, Bertrand.
Thank you, Tilly. It was very good to hear how Edvance has been developing its strategy to support projects in UK, and in particular, from my side, I take note of the point that Hinkley Point C and Sizewell will have different organizational structure, and that's something you're factoring in your strategies, which is a perfect transition for Bertrand, who is going to tell us about the Sizewell C project and how you're approaching delivery and in particular replication from Hinkley Point. Bertrand, over to you.
Thanks a lot, and very pleased to be here with you today, and pleased to be speaking about Sizewell together with Julia. So I will cover the easy part, which is just how we copy in clay, and which is what we call the next of a kind part of a project. And Julia will cover the more difficult part, which is how we finance it, which is first of a kind for a nuclear project, and she will detail how we are managing that. A few words about what we have been doing on Sizewell in order to develop the project and to make it a viable option for the UK government in its energy policy. And highlighting first the fact that Sizewell C started long time ago. Actually, the first row of public consultation was in 2012. And we went through 4 series of public consultation just to highlight that those big projects are indeed big engineering projects, involve a lot of people from the supply chain, but first and above all, they are projects that have to be developed in a neighborhood, in a place where people are not necessarily expecting a big disruption for 10 years of construction work. So it's critically important when we develop such projects to make sure that we consult local communities and understand their concerns and, as far as possible, address their concerns. A big part of our activities has been about securing replication, as you just highlighted. And it can appear relatively straightforward, but actually, when we said initially we wanted to replicate Hinckley, it was not necessarily something that was well accepted. Everyone understands the principle of it. The practicalities of how we replicate can be challenging. And when I was discussing with my engineering colleagues, they were looking at me saying, oh, guys, we don't believe you. We just don't believe that you will replicate the supply chain. We think that you will go back to the market, go through some competitive tender, you will bring new suppliers, and we will get a lot of changes. And we demonstrated that we can replicate the supply chain. We have exactly the same suppliers than the ones that are involved at Hinckley, apart from one who didn't want to support the project. And to be fair, the behavior of the supply chain has been very positive. And we are getting, I think, what is a fair and reasonable proposals from the supply chain when we discuss with them. The other part, and it's a little bit the other way around, when we were discussing with suppliers on Hinckley, they were saying, okay, we understand replication, but will you be able to manage your stakeholders? Will you be able to manage engineering? How sure are you that they will not generate a lot of changes as we had between Flamanville, Hinckley? So there was also an issue of credibility there. And the first step for us was to secure the fact that the environment in terms of regulation will be consistent. And thanks to the work that has been done by Hinckley in securing a good relationship with the UNR, with the environmental agencies, demonstrating that Hinckley design is a solid design that can support safe operation of the plants, we were able to secure that regulatory environment. And I must say that the UK regulators have been very positive and supportive of the notion of replication, because they understand that on the long run, on the long term, it's probably the best thing that can happen for the safety of the operation of both Hinckley and Sizewell units. And the third point that was important for us to secure is to establish Sizewell C as a credible organization. The financing framework will be different from Hinckley. We will see that with Julia later on. It means that our shareholders will be different. Sizewell C will be a different licensee. We will rely, obviously, on a number of shared services, supports, such as the UK EPR Design Center, such as the technical client organization that Mark has established in the UK. Nevertheless, we need to be able to demonstrate that Sizewell C Co, as a standalone organization, part of the broader EPR family, but as a licensee, will be capable organization, capable to make decisions and to operate the plant safely. So this is part of the journey we went through, and this is basically what was shared and demonstrated to the UNR and VEA as part of our nuclear site license application process that is getting to completion now with feedback expected in July. So what is ahead of us? It's really going through a number of critical milestones in July. We will go through a decision on the development consent order, which is a kind of equivalent of DAC and permis de construire. We will get feedback on our licensability. Is Sizewell-C capable to be a licensee? This is something the ONR and the EA will give us some feedback in July. And importantly, we have also a critical milestone in July, which is what we call government investment decision. This is the moment in time where we expect the UK government to be directly involved in the project alongside EDF. And then EDF and the UK government will support the project, further develop the project up to the FEED. And at that point, we will be delighted to be joining EPROG and be part of a broader family. So this is, I would say, a very quick snapshot of what we have been doing and what it means for us to replicate. Just a brief view of the timeline, and you have on that slide both the high-level Hinkley timeline and Sizewell-C timeline. The point around that those two timelines is really to demonstrate that we have the opportunity to get a mature design from Hinkley before we copy it and we replicate it. Replication is about design, but it's also critically and crucially about people. We are also working alongside our Hinkley colleagues, alongside our supply chain colleagues, to make sure that we can transfer processes, skills, in order to make sure that we deliver Sizewell efficiently, that we capture the improvements that we can see already and that Mark detailed on Hinkley between Unit 1 and Unit 2. And our target, obviously, is to get those positive results on Unit 3 and 4. I just wanted also to highlight briefly that we are already replicating. Replication does work. We have started some manufacturing for Class 1 components with Framatome as part of an anticipation program. We call it anticipation program. It's not a program that is required by the schedule, because actually we have plenty of time to manufacture those components. It's an anticipation program that is driven by the skills and the requirement to secure continuity of manufacturing activities within our supply chain. So this is what we are doing with Framatome now already. This is what we will be starting to do as soon as we get through financial close. And what we are seeing with Framatome is that basically we can confirm the benefit of reusing exactly the same documentation, the same inspection test documents than the ones that have been used at Hinkley for Sizewell. We are saving an awful lot of time. We are getting straight to the point. We are embarking Hinkley lessons learned, because there are obviously lessons learned that are meaningful for us. And we are benefiting for, I would say, a swift and smooth process. Again, thanks to all the hard work that has been done upfront by Hinkley with the supply chain. So good progress to date in order to secure replication. Replication is already in action, and we see the benefit of it. I'm not naive. I know that it needs to be secure on the long run. There are some issues. There are some obsolescence issues that we're mitigating with some early procurement of critical components. But the first steps we have taken are very positive, encouraging, and again, based on Hinkley lessons learned, all the huge effort that Hinkley has been doing in developing the supply chain in the UK for the delivery of a project. I'm confident that we will be able to secure a solid case for Sizewell, and hopefully we will get to the point where we will be joining EPROG in 1 year from now. I hand over to Julia, who hopefully shall be on the phone to discuss.
Thank you very much, Bertrand, for this overview. I take note that delivery is in action, And I also understand that on your critical path to secure a replication, there is financing. And so here is a transition for Julia's presentation about financing for Sizewell C. Yes.
Thanks.
Hello, Julia.
So I think the first thing to say about financing is that everything we've done is based on all of the work done by Mark Stewart and team at Hinkley, and of course by EDF and Edvance, and by Bertrand and team on the replication of Hinkley at Sizewell, and of course by all of you in the supply chain who are making the power station real. So step one with getting Sizewell going from a financial perspective was to look at whether or not we thought the regulated asset-based model could work for new nuclear in the UK. And we concluded that it could, and that it could reduce the costs of new nuclear to consumers. If we remember that the majority of the cost of Hinkley to consumers, of the £92.50 per megawatt hour, is made up of the cost of money, you can see the importance of finding a new way of financing for Sizewell. So the second step was to persuade the UK government to implement the RAB model. And the first element of that journey was to show that we could replicate, and that Sizewell would have lower costs and a much lower risk of cost overrun than Hinkley. And that's because what the RAB model does, so the regulated asset-based model, which is the way of financing which is used for electricity transmission assets, it's used for electricity distribution networks, it's used for water companies in the UK, it's used for airports. I think it's quite similar to the way that the French grid is financed. So we had to, what the RAB model does is it shares construction cost risk between consumers and shareholders, and it caps the shareholder element of the risk and the consumer element of the risk by giving extreme risk at a remote level to UK taxpayers. So in deciding whether or not to implement the regulated asset-based model for new nuclear, the government had to be confident that new nuclear could deserve the RAB model, and they could be sufficiently confident in the costs, in our ability to replicate, and in therefore the lower risk of construction cost overrun in order to implement it. So the second part of persuading the government to implement the RAB model, aside from can we show that we deserve it, is to work with politicians and energy bodies and the media to create the conditions in which the government would be politically able to implement the RAB model. So we had to have a lot of focus on improving the narrative around nuclear in order that the government would feel confident in bringing forward the necessary legislation. So the good news is that work paid off, and that work has been done by a wide group of people, including in particular a lot of people in the supply chain, of course our colleagues in Hinkley and the Sizewell team and the government themselves. And the government has passed the legislation, so we now have a regulated asset-based model for new nuclear, so something which shares construction cost overrun risk in the UK. And it was very important to us that we had political support from all parties, so both from our current government, the Conservative Party, and from the main opposition, the Labour Party, because, as you all know, nuclear is a very long-term game, and you need consistent political support for whoever is going to be in power from time to time over the 70 or so years of construction and operation. So then government had to look specifically at whether or not Sizewell could deserve and be allocated a license to use the regulated asset-based model. And the good news is that the government published a couple of weeks ago its findings that Sizewell indeed could deserve the RAB model. So there's a formal consultation process, but the government has published that it's examined Sizewell's costs and its construction cost overrun and concluded that it can have the regulated asset-based model subject only to the outcome of the consultation. So where we are now is with a model against which we can raise money. And so the first step in raising the money is to persuade credit rating agencies who have never had to look at rating new nuclear build as a project can the credit rating agencies get comfortable that the large quantities of debt that Sizewell needs to raise can be investment-grade debt? It needs to be investment-grade debt if we're going to be able to raise it at a reasonable cost. So this is where we are now, in the middle of this process. And although I'm talking about it, Bertrand is very much involved. We've taken the rating agencies down to Hinckley, and they've spent a lot of time talking to Stuart and Mark, because what they have to get comfortable with is that it's a good project, not just that the money gets paid back, but also that it's a good project. So we're in the middle of this process, and we expect to get the results of our work next month. So the next step, as Bertrand referred to, assuming that we get our credit rating, is that government, we hope, is going to come along and invest as a shareholder. And then with government in place as a shareholder, so 50-50 EDF and government, we then raise the money that we need, both the equity and all of the debt, sign all of our contracts, and we get building. And we end up, we hope, with a shareholder mix which has EDF at around 20%, UK government at around about the same, and the majority of the shareholding being held by financial investors. So in conclusion, I'd say a lot of financing is technical. There's lots of, obviously, of technical work to do, but a lot of it is emotional and political. Bankers are people. Bankers need to want to lend to nuclear. And so we need the finance community to accept that nuclear is green. Nuclear is a good thing. It's necessary, and it's going to help us fight climate change and create all of the jobs and social benefits that we all know that it does. We have to persuade other people. So I'd say the tide is turning, but it's a continual work, and it's something that we can really all do together. Everybody involved in new nuclear build can participate in the continuous effort to improve the narrative around nuclear. And it's in improving the narrative that we actually find that we are able to raise money, and that we're able to make that money as cheap as it can be, which brings down the cost of nuclear to consumers. And so it makes a virtuous circle. So I'll stop there, because I think we now want to leave time for a panel debate.
Yes, thank you very much, Julia, for your intervention. Yes, the mic is working, and I take from your presentation that we look forward for news regarding credit rating in a month from now. So now we have about half an hour for Q&A, and I will kickstart with a question, maybe to all panelists, or at least most of them. There has been a few statements from the UK government looking for an increase in nuclear capacity. Very recently, with suggestion of up to 24 gigawatt of nuclear being required by 2050. So my question really to all of you is, what is your view on the opportunities this creates for the UK nuclear landscape? Who wants to start? Maybe Mark, you're next to me.
Yeah, so I can start, and I'm sure others will have plenty of comments as well, Julia and Bertrand talking about the overall landscape. So, I mean, government have set out in their policy, thinking about this 2050 and 24 gigawatts as an ambition, and before that to get to effectively having 95% low carbon energy by 2030. So quite ambitious targets in terms of how we move that forward. If you think about a number like 24 gigawatts, then that's quite significant, especially when we put that in context of the older nuclear power plants in the UK are starting to get to the point of closure. We're already in a position where Hunterston B has shut down and is being defueled. Dungeness is also shut down, and Hinkley Point B will shut down later this summer. So we're starting to see that tail off as well. So with that in mind, it says to me personally that there is a need for large nuclear in terms of bringing some of that capacity, gigawatt nuclear. And there's been talk about a number of the different sites. Clearly, there's a lot of our focus has been on Sizewell. There's discussion of both Wilfer, Moorside, etc., in terms of other sites which are suitable for large nuclear. And of course, lots of discussion about what technology might be put on that, whether that be further EPRs or whether it be, for the sake of argument, AP1000 or so on. There's, of course, also an ongoing debate over small modular reactors, and a huge range, is my observation, of what small modular reactors might be. It's a term that's used for many, many different things, ranging from something that effectively is 0.5 gigawatt and a distributed PWR, so like a baby EPR, through to sort of plants that are very, very different in terms of their design, bring in the ideas of passive safety, some of them are sodium cooled, all of these sorts of things. So exactly what that means, how those things would be utilised, I think is an ongoing debate now with government. And I think the best thing we can have as an industry is a sort of programmatic approach, which is hugely important to get some sort of sustainability within the supply chain and within our skills and capability going forward.
Thank you, Mark. Who wants to go next? Bertrand.
Just to highlight that the ambition brings a lot of opportunities, but we need also to understand that developing those projects takes time and is quite expensive. So there is a question about how those projects and the development cost of those projects can be supported by government, because it took a lot of money to bring Hinkley to feed. On Sizewell, we will have spent more than £1 billion before we get to that point. So you need to have the right arrangements in place to support that development of big projects.
Aude, what are your views on the UK in general, and how are you getting ready for future projects?
I think for me, the opportunity as a member of the supply chain exceeds just the UK. I mean, for us, when we were awarded the Polar Crane contract for HPC, it was the revival of the nuclear new builds of a certain magnitude. And the fact that there was not only one, but two units with a certain overlap, so, but also the perspectives of two other units, and with the, the growing EPR family, not only in the UK. And I think, repetition, keeping the momentum, there's nothing worse than demobilizing and remobilizing a supply chain, particularly when it happens over a decade. And even lessons learned on the experience on site, lessons learned in the design. If you implement the return of experience more than a decade afterwards, it's not the same thing, probably it's not the same people, so even, it's a challenge to keep the knowledge internally as an industrial company, but still, so keeping the momentum, keeping moving, and the difference between a project and a product is repeatability and the time span. So I can only, the opportunity is for the whole industrial supply chain, for the whole industrial chain, that there is this momentum, this rhythm, and this is how we will build the future, I believe.
Maybe, Tilly, you could provide a perspective, and I have in mind also the issue of managing the talent pipeline with these large ambitions for new nuclear in the UK. How are you approaching this at Edvance?
So Julia spoke very well about changing the narrative around nuclear. That obviously has or can have huge benefits from a political standpoint, but it also can have huge benefits around an attractiveness perspective in terms of the industry. It's probably fair to say that historically we haven't necessarily been seen as the most attractive place to come and work, and I think in the last few years we've really seen that narrative change, particularly making a very clear and strong link towards the role that nuclear can play in decarbonising the energy sector, and that has, especially, I think we see more in the younger people that want to come and work with us, that has a huge, a real role to play, I think, in making nuclear seem to be a place that people want to come and have their careers. It was interesting, I was at another conference, and there was some people from some of the big oil and gas companies, and 10 years ago they were the people that were attracting the best graduates in kind of en masse at least, and actually that's completely changed now, and a significant portion of people who are coming out of school, coming out of university, really want to have a job which links to and has a key role in the climate change agenda. So I think a commitment of the order of the 24 gigawatts, clearly that gives, I think, a level of visibility and opportunity longer term for people to come and want to join us. Nevertheless, I think both Aude and Mark have touched on it quite nicely. We are doing something that hasn't been done for decades, and so that sort of rejuvenation of a supply chain, it's rejuvenation of a sector. In some cases, in the UK, that's definitely the case from a nuclear new build standpoint. And so we've gone through an extremely steep curve in developing the HPC organisation. That continues with the perspectives from Sizewell. But I think we would all recognise that we're also in quite a tight and competitive market in the UK. We're not. We have been up until now really the kind of major player in town. That's not necessarily going to be the case going forward. And so, you know, I think there's a real opportunity, but with that comes a challenge as to how do you reach out to sectors and types of the population who maybe historically haven't wanted to go into careers in the energy industry or in technical disciplines or even in non-technical disciplines, but that are related to nuclear. How do we really expand our reach so that we are accessing the full potential of our countries, and not maybe just the historical roots and the pipelines that we've had in the past, but really thinking about how do you access, you know, from a diversity perspective, but also just in terms of the sheer volume of skills that we're going to need, as far-reaching a group of people as possible. So I don't have any solutions, but more that creates an opportunity, and I think we've got a collective obligation to really try and work on that if we want to be able to, you know, meet the heights of some of the ambitions that are being set.
Mark, you're very much in this game right now in terms of managing talent for Hinkley Point. Did you want to comment on that from your perspective?
Yeah, I mean, I think Tilly's put it very well about the sort of the ambition and the need overall. I mean, where we are at the moment is we spend a lot of time on trying to have multiple entry points, multiple pipelines for people, so that things like all the apprenticeships that allow access for people to get that development, bring on their careers, bringing in graduates as well for those sort of engineering type roles and all of that sort of thing, working with the local community as well for different opportunities within suppliers as well as within, you know, the project and EDF itself. I think then also with, and people will have heard perhaps of Great British Nuclear, you know, government setting up an agency which they're thinking about exactly what role that will take in terms of development of nuclear in the UK. And I suppose one of the key roles it might take would be about looking more broadly at skills requirement within the UK and how to really bring all of that together across a nuclear industry as a whole. So not just whether it be Hinkley, Sizewell, EDF or whatever. I think the last point I'd make is of course we spend an awful lot of time working in partnership with you know, all of the people across the industry, particularly within the UK, with government agencies and so on as well. So we look very carefully at the skills across all of those things to see how we can bring that on. And I suppose what all of us need within that is a level of certainty, don't we? We need to be able to plan for these things, and then you can grow the capability.
Thank you, Mark. We talked a lot about, and quite rightly so, about partnership and cooperation. I do have a question for Bertrand and Julia in particular, because, you know, replication strategy will mean you won't go through competitive tenders for your supply chain. So the question that comes to mind to many is how can you ensure that you keep value for money as you move towards a final decision for Sizewell C?
indeed, it was not necessarily completely straightforward to convince everyone that we will not compete any of our contracts, because it's alien to a lot of principles that people may have, especially when we are in the region of public procurement policy. So what really it is about, first of all, it's building on the solid relationship that Hinkley did build with its supply chain. I mean, Chris is in the room, is instrumental to that. And it's just engaging, I would say, on a grown-up basis, acknowledging that there are some benefits that comes from replication and engaging on the supply chain about, okay, what kind of savings do you see in terms of engineering qualification? Acknowledging also that in some areas, the supply chain may have some issues in the way they have estimated the cost of Hinkley. So I think that honest, open approach did work up to now. And again, I've not seen any bad behaviors from the key supply chain partners. And from a Sizewell C perspective, obviously, it's taking a broader view of the overall economics of the project. Yes, we may get a better deal, contract per contract, by going back to the market, trying to bring someone new who could help us to save a couple of % on a specific contract. But it's just acknowledging that the knock-on effects are so negative overall that it's not something that will bring value for money for the project. And again, as Julia mentioned, a key part of what we are selling, it's not only cost, it's also a risk profile. And using the same contractors, experienced contractors, drastically reduce the risk, which is key when we are engaged with potential investors and financials. Julia, do you want to develop that point, perhaps?
Briefly, that one way we ensure value for money is by the government insisting, correctly, that Sizewell will only offer value for money to UK consumers if it comes in at a certain capital cost. And so there is a point beyond which the project simply won't happen if the costs are too high. And that's a continual corrective and ensures that what is being proposed does offer value for money, because it is the only way the project will happen.
Thank you, Julia. I have many more questions, but I'm also mindful of the time, and I expect from the room we have a few questions. I see a couple of hands raised. Valérie, you are the front. You go first, and then just fine.
Thank you very much. I have a question. I'm not sure you've said how much you expect in terms of series effect from HPC into Sizewell C. And I also wondered, because in France we've been asking for at least visibility on 6 units. Do you feel that you need right now to have some visibility as well on a third pair to be able to hire and also to motivate your suppliers?
On the second part of the question, which is around visibility on a third pair, clearly we are giving with 2 additional units significant visibility to the supply chain already. So yes, there may be other options later on, but I think we are quite busy securing the right capabilities to deliver Sizewell. And again, I mean, you have seen the timeline. We are speaking of activities that will be developed up to 2035. So it's already quite a significant amount of works and workload that we are discussing with our supply chain partners. And yeah, there may be some plus on top of that, but we are not engaging on the basis that there may be another couple of units. I'm not sure to have exactly properly understood the first part of the cost savings from Hinkley to Sizewell. As Julia said, we are looking at overall. Our target when it comes to what we call technology and equipment contracts, that is to say not site-related activities, is to have a cost reduction between 15% to 20%. And up to now, we are in that range with our main partners and main contractors. Again, mostly thanks to the fact that we are not replicating any qualification activities. We benefit from what has been done on Hinkley, and we are significantly, drastically reducing the volume of design activities because there is a limited volume of design to be done.
Maybe one point on the visibility for the supply chain, because there is the supply chain and the supply chain of the supply chain. So it shouldn't cascade too much, which raises the question of the verticalization. Do you make or do you buy? So the tier one subcontractors are going to have the visibility. We have the visibility. We can get ourselves organized, but it's our own supply chain. I think I tried to show a hint of that, how that could be complicated, what challenges they were. So the welders that the fabricant of the quadrilateral has hired, educated to keep that level of education, he needs to have visibility as well. And then in the visibility that we have as tier one supplier, we could also do things more verticalized. For example, the electrical cabinets of the polar crane for Flamanville, we subcontracted. The electrical cabinets for the polar crane of HPC, we've done ourselves. We could probably also do more, and this could be done by acquiring competences in-house or maybe doing certain acquisition. But obviously, we have the visibility to keep our own resources mobilized, but I think today we don't have sufficient visibility to grow or to invest heavily, because if we acquire one of our suppliers that is essential to our fabrication, how do we keep him busy in the meantime? So this is why actually it's there are different levels of the supply chain, different levels of visibility, and we have to have a certain degree of certainty to be able to mobilize our own supply chain. So there is this cascade effect, and we see, the devil is in the detail, and sometimes one of this lower tier subcontractor, although having a very small portion thereof, if it's an element that is on the critical path, it can have an impact.
Other questions? I think, gentleman on the left.
Yes, perhaps I did not listen carefully enough, but I wondered what was the role of CGN in the project. And another question is, do you have any Chinese suppliers in the supply chain for the project?
Mark, I think this is for you.
So within the Hinkley project, CGN are a 1/3 shareholder within the project. Of course, they have a huge nuclear heritage as well, and a lot of construction experience, which they bring to that project to help bring across the experience from having built Taishan and all of those sorts of things. So again, it's another opportunity for learning from both of our shareholders, from both EDF and from CGN, bringing that learning across. So in terms of their role, they obviously have a role as a shareholder in that sense, but they also have a role as an industrial partner in terms of bringing experience in. As far as the supply chain is concerned, there is a fairly limited amount of supply that comes from China, but there are a small number of equipment-related contracts and things like that that are placed in those. For example, some heat exchangers or things of that nature.
Thank you, Mark. I think we have probably time for at least one more question. Valérie has her hand raised again, and then Philippe as well.
Yes, I think Mark talked about the digital twin. I think HPC and probably Sizewell as some of the first EPR projects which are using so much digital technology. So I wanted to know, what is your takeaway from it? Did you really achieve the productivity gains from the digital technology? And what progress are you making in processes between HPC and Sizewell C in that regard? Are you using full PLM for Sizewell C?
So perhaps if I start and then Bertrand can draw the link to Sizewell. So in Hinkley, we have a full 3D model. Often gets referred to in construction as 4D or 5D because you integrate the time of the construction sequence into that as well. We've seen quite big benefits if we look back at the learning from Flamerville, say, about the placement of the embedded plates. So these are the plates that equipment is welded onto or connected to, and within the design, they're all fitted into the civil construction as it is built. The big benefit of the 3D model is you place those right first time. You get your rebar in the right position so that they go where they're supposed to be, rather than you having to adjust those things on site. So that does give, an efficiency improvement. I think the other area I'd pull out that we're starting to see is when we look at the complexity of mechanical, electrical, HVAC fit out, and bringing large pieces of equipment into what is quite a complex structure of rooms, to be able to see a model where actually you can model this all in time. So we know the installation sequence that these things need to be done in because it's been physically modeled in a three-dimensional model first. And some of the rooms, you can only build them in certain order. We know that larger pieces of equipment will have to go in first. But then we can review that sequence compared with other rooms, because depending on what else is going on will depend the route we have to take and all of those sorts of things. So it allows that level of planning, which I think is a great benefit. Now, of course, there's then a transfer across to a sister plant, which Bertrand might want to comment on as well.
Maybe I can just add one other point. We're in the process on HPC of integrating within that same 3D model all of the execution design that is done by our suppliers in the mechanical, electrical, and HVAC areas, in addition to the design that's done by us. So we do the detailed design, we hand that over to the execution, the strategic suppliers who do the execution design, and then the manufacturing of things like pipework, cabling, etc. And we're in the process of bringing all of those suppliers into the same 3D model, and so they do their execution design directly within the same environment that our design, the overall design, has been done. And that in a similar way to the example that Mark gave for the civils program, where you're able to declash the interface between the rebar and the anchor plates, it also means that therefore the execution designer has got the full visibility of everything else in that environment. And if that is updated and changed as things go on, they are also seeing that in real time. And so that you're essentially, hopefully, de-risking potential interface clashes and things that you may only have discovered later on. So it's an integrated model, but it's including suppliers within that in an extended enterprise way of working.
Obviously, we are building on those works. I just wanted to add that there is the design element of the information systems, and there is all the project management element of those systems, and all the logistical aspects, because we have to manage millions of components that needs to be procured, quality checked, stored, assembled, installed, commissioned, and so on. And using capability of the proper information systems to properly and effectively manage those components during the execution of the project, with all the quality records attached to that, is also a key area where I think we can significantly improve compared to what has been done. And Hinkley is investing a lot already in that area, so we are willing to benefit from that and go one step further with, I would say, more standard requirements with our supply chain in this field, because I think we can save a lot of efforts and improve drastically the tracking and recording systems with better use of digital technology.
I think in terms of replication from a design perspective, being able to take what is essentially the site-compliant model from HPC, so the final design that is given to the construction contractors to build, having that in an integrated, usable manner that is then the starting point for Sizewell. If we don't have that level of data quality and completeness in that way, it makes replication a lot more difficult. So it's needed for HPC. It's absolutely really beneficial for the HPC operator, but it's also really critical to then be able to have a sequence of replication.
I think our time is up, so it's down to me to thank our panelists for a very exciting discussion, and it was very good to see all this progress with Hinkley Point C delivery, progress with Saswell C planning. I also take that this project in the UK are really setting a standard in terms of supply chain collaboration, both as a first year and also working with the supply chain and of the supply chain. And I think all this experience is going to be very inspiring for future EPR project, and we'll have time to come back to that during some of the panel this afternoon. So, Valérie. Okay. First, thank you.